Hello everyone, welcome to my course on JavaScript. Today I will show you the different types of JavaScript operators, including arithmetic operators, ternary operators, bitwise operators, logical operators, comparison operators, and assignment operators. First, let's take a look at the most basic arithmetic operations: addition, subtraction, multiplication, and division. Please be aware that these operations apply to not only numbers, but strings as well. Add one string to another is equivalent to string concatenation. You can even add a number to a string, or vice versa. In both cases, the number will be converted to string, followed by the string concatenation operation. For example, number 3 plus the string 4 equals string 34. For all other arithmetic operations, including subtraction, multiplication, division, and more operations that we'll soon talk about, strings will be converted to numbers whenever possible. If a string cannot be converted to a number, it will result in value of nan, which means not a number. Few examples below. 7 minus string 3 equals 4. String 3 times string 4 equals 12. 9 divided by 4 equals 2.25. Let's move on to more arithmetic operations. Exponentiation. Exponentiation is denoted by two consecutive asterisk symbols. The exponentiation operation of x and y means multiplying the value of x by itself for y times. For example, 3 to the power of 2 means 3 times 3, which is 9. Modulus. Modulus is denoted by the percent symbol. It is the operation to find the remainder after dividing one number by another. For example, 9 divided by 4 equals 2, with a remainder of 1. So the modulus operation of 9 and 4 gives the output of 1. Modulus keeps the sign of the left operand, ignores the sign of the right operand. Thus, minus 9 modulus 4 equals minus 1. 9 modulus minus 4 is same as 9 modulus 4, which equals 1. Minus 9 modulus minus 4 equals minus 9 modulus 4 equals minus 1. Most operators requires two operands. However, there are exceptions. Ternary plus. The ternary plus operator will convert the operand into a number, if it is not already. For example, plus 1 equals 1, plus minus 1 equals minus 1, plus true equals 1, plus empty string equals 0, plus string 100 equals number 100, plus hello equals nan, plus undefined equals nan, plus nan equals nan. Ternary negative. The ternary negative operator negates its operand. The ternary negative operator can convert a non-number into a number. For example, minus string 4 equals minus 4. Increment. The increment operator applies to one variable. It has two versions, the postfix increment denoted by plus plus x, and the prefix increment denoted by x plus plus, where x is the variable the increment operation is applied to. Take a simple example of x equals 3. When you print the value of x plus plus, you will get 3, afterwards x is increased by 1. However, if you print the value of plus plus x, x will first be increased to 4, then printed. You will see a print out of 4. In both cases, the value of x is increased to 4 after the increment operation. Decrement. The decrement operator is opposite to the increment operator. It reduced the value by 1, with 2 versions of pre- and postfix as well. If y equals 3, the output of y minus minus is 3, whereas the output of minus minus y is 2. In both cases, the value of y is reduced to 2 after the decrement operation. Left shift. The left shift operator returns a number whose binary representation is the first operand shifted by the specified number of bits to the left. Excess bits shifted off to the left are discarded, and 0 bits are shifted in from the right. For example, 5 left shift by 3 equals 40. A number left shifted by x is equivalent to the number multiplied by 2 to the power of x. That is, 5 left shifted by 3 equals 5 times 2 to the power of 3, which is 5 times 8, and the result is 40. Right shift. The right shift operator returns a number whose binary representation is the first operand shifted by the specified number of bits to the right. Excess bits shifted off to the right are discarded, and copies of the leftmost bit are shifted in from the left. This operation is also called sign propagating right shift or arithmetic right shift, because the sign of the resulting number is the same as the sign of the first operand. For example, 40 right shift by 3 equals 5, minus 40 right shift by 3 equals minus 5. Unsigned right shift. The unsigned right shift operator returns a number whose binary representation is the first operand shifted by the specified number of bits to the right. Excess bits shifted off to the right are discarded, and 0 bits are shifted in from the left. This operation is also called zero-filling right shift, because the sign bit becomes 0, so the resulting number is always positive. For example, 40 unsigned shift by 3 equals 5, minus 40 unsigned shift by 3 equals 5, 3, 6, 8, 7, 0, 9, 0, 7. There is one and only one operator that takes 3 operands. It is called the conditional operator, also known as the ternary operator. The conditional operator starts with a condition, followed by a question mark, then an expression to execute if the condition is true, followed by a colon, and finally the expression to execute if the condition is false. This operator is frequently used as an alternative to an if-else statement. For example, with condition of true, the outcome is the left operand, which is 3. With condition of false, the outcome is the right operand, which is 4. Similar to the conditional operator, but takes only 2 operands, is the nullish coalescing operator. The nullish coalescing operator returns its right-hand side operand when its left-hand side operand is null or undefined, and vice versa. For example, nullish coalescing of 4 and 5 equals 4, while nullish coalescing of null and 5 equals 5. Please be aware that false is not null, thus, nullish coalescing of false and 5 will result in false. JavaScript supports bitwise operators. Let's take a look. Bitwise AND. The bitwise AND operator returns a number whose binary representation is 1 in each bit position if the corresponding bits of both operands are 1. For example, bitwise AND of 3 and 5 gives 1. This is because 3 can be written as binary 011, and 5 equals binary 101. Another example, bitwise AND of 7 and 6 gives 6. Bitwise OR. The bitwise OR operator returns a number whose binary representation is 1 in each bit position if the corresponding bits of either or both operands are 1. For example, bitwise OR of 3 and 5 gives 7. Bitwise XOR. The bitwise XOR operator returns a number whose binary representation is 1 in each bit position if the corresponding bits of the operands are different. For example, bitwise XOR of 3 and 5 gives 6. Bitwise NOT. The bitwise NOT operator returns a number whose binary representation is 1 in each bit position if the corresponding bit of the operand is 0, and vice versa. The bitwise NOT operation also changes the sign bit. The result is always with a different sign as the operand. Use it with caution. For example, bitwise not of 3 gives -4, bitwise not of -5 gives 4. Okay, let's move on to logical operators. Logical AND. The logical AND operator is true if and only if all the operands are true, otherwise it will be false. The logical AND operator returns the value of the first false operand from left to right, or the value of the last operand if they are all true. Examples of expressions that can be converted to false are false, null, nan, 0, empty string, undefined. For example, 3 and 4 equals 4, 0 and 4 equals 0. When you convert the returned value to Boolean, you will get true for the first example, and false for the second one. Using logical AND for short-circuit evaluation, the logical AND expression is a short-circuit operator. As each operand is converted to a Boolean, if the result of one conversion is found to be false, the AND operator stops and returns the original value of that false operand. It does not evaluate any of the remaining operands. Consider this code: false and skipped expression. The skipped expression is never evaluated because the first operand is false. Logical OR. The logical OR operator is true if one or more of its operands is true. The logical OR operator returns the value of the first true operand from left to right, or the value of the last operand if they are all false. The logical OR operator can also be used for short-circuit evaluation. The expressions after the first true operand are not evaluated. For example, true or skipped expression, the skipped expression is not evaluated. Logical NOT. The logical NOT operator converts true to false, and vice versa. Comparisons. I will skip the very basic comparison operators: less than or equal to, greater than or equal to, equality, inequality. I'm sure you all know these operations. However, be aware that JavaScript supports comparison of both string and number, and a mixture of the two. When the operands have both string and number, the string is converted to number. Check these examples. String 3 is less than number 4. Number 11 is less than string 1, 0, 1. String 3 is equal to number 3. Number 101 is greater than number 11. String 1, 1 is larger than string 1, 0, 1. The number 1 is considered as equal to the string 1. The number 0 equals to false, and also equals to an empty string. To avoid surprises, it's recommended to explicitly convert the operands to the data type you want. Another way to avoid the type conversion during equality check is the strict equality or the strict inequality operator. The strict comparison will return false if the operands are of different types. Only if they have the same time, their values will be compared. For examples, number 1 is not strictly equal to string 1, number 0 is not strictly equal to false. Finally, let's talk about assignment operations. The very basic, and mostly used one is the assignment operator, denoted by symbol equals. The assignment operator is used to assign a value to a variable or property. The assignment expression itself has a value, which is the assigned value. This allows multiple assignments to be chained in order to assign a single value to multiple variables. For example, x equals y equals 4. This will not only assign 4 to y, but also assign the value of y equals 4, which is also 4, to x. The previously mentioned operators that works on two operands can also be combined together with the assignment operator. For example, x multiply equals 4. This is the same as x equals x times 4. X or equals 4. It's same as x equals x or 4. X left shift equals 4. Is same as x equals x left shift 4. When nullish coalescing operator is combined with assignment operator, the combined operation is called the nullish coalescing assignment. The nullish coalescing assignment operator, also known as the logical nullish assignment operator, only evaluates the right operand and assigns to the left if the left operand is nullish. For example, if x equals 3, nullish assignment of x and 4 still keeps the original value of 3. If x is undefined, nullish assignment of x and 4 will change x to 4. The nullish coalescing assignment operator is often used to apply default values to object properties. In this case, the nullish coalescing assignment applies the default value if the property has value null. Take for example an object with two fields, x and y. The value of x is 1, the value of y is undefined. After applying the default value of 100 to both x and y is initialized to 100, while x keeps its original value of 1. Thanks for watching. If you like this video, please give your thumb up. Bye.